So in this video, I'm going to show you how you can use the model function to analyse your different growth curves. So in this example, I've used for Algem HU24 to analyse some transformants I made. And what I want to do is show that they can grow essentially the same with the antibiotic as they can without the antibiotic. And I've also compared them to wild type. So I want to compare their growth rates. I did this in triplicate. And what I prefer to do is analyse the growth rates of each run separately and then average them and then work out standard error or standard deviation on them. So in order to do that, you want to load all of your HU24 plots up together as individual runs. And you want to make sure that the model actually does fit these runs, because if it doesn't fit, then obviously it's going to give you an invalid results and you can't use that to compare them. So the first thing I do is I compare all of my runs individually and I've basically, instead of loading all 24 at once, I've just loaded the ones that I'm first interested in, and I will fit the model to these curves to make sure it's a nice fit. Now, as you can see, something weird seemed to happen up here. I probably opened the lid or something weird. So I'm only really interested in this part of the curve. So to do that, to individually look at them, you use this button here called fit. So you pick whichever one you're interested in. So I'm going to look at this blue line one first. You then select which model you want to fit. So obviously I'm interested in the Zweitering et al. Model because it's actually based off microbial growth rates in batch cultures, so it's very relevant. And I'm going to pick the time units where I want to fit the model to. So I've already done this. I know that between 0 and 80 creates a nice fit. And then I'm going to select fit. And as you can see, I get a nice fit curve here. It's really snug fit. It's clearly done a really good job. Now, with this line here, though, this is where I've grown my wild type with zeocin. I'm probably not going to get such a good fit because obviously this isn't showing a growth curve you'd expect. So if I was to fit this one, which I believe is B1, I'm probably not going to get a good fit. So this means I'm most likely going to want to exclude this from my data because I might get an error, or it might, I'm sorry, do 80 again. It might just not work, or if it does work, it might not fit very well. So you see, actually, no, it has tried to fit it, but it's not perfect. So I probably would exclude this from my results and just say the growth rate is 0 for this. And then, you can carry on going, so I can fit this nice magenta one, which I think is B5. And again, just to demonstrate that although the growth rate is slightly different, you can still get a really good snug fit. Oh, but I forgot to change it to the Zweitering model, so that's easily done. So make sure you change it. So 0 to 80. Lovely, and again, a nice fit. So you could go higher if you wanted. If you fit all the way, if it looks like it's going to fit all the way nicely up to 130 or whatever, you can do that. If you want, you can individually assess these as well. So if you go to your stats tab, you select. So actually, when you load up Ada, normally it just gives you 2 significant figures when in the model, but I like to up this to at least 4. And then what you can do is select these options to show the model fit text, the parameters, and the errors. And this time when you plot, it will tell you what the different factors are. So this is biomass yield, this is your growth rate, this is your lag phase. And obviously it's helpful to have a legend as well if you want. So if you put your legend on, it will tell you what your red line's the fit button. Okay, great. So, I mean, it's good generally to make sure the model does fit individually to all your lines. But if you're in a massive rush, you want to really quickly compare it, what you can do is use the table function. So here I'm just going to decide to plot all of my different reactors together. There we go. I'm going to take my legend off because it's confusing. And click fit off. So if you want to now, instead of having to manually write down the fit model for each parameter, as I just showed you, because it will just pop up, you can use this function here, to table. And all you do is you select this, you select whatever you're interested in. So in this video, we're interested in the fit of the model and the parameters that get spat out from it, and you select add row. So I'm interested in, let's say, the growth rate and my biomass yield. And I'm interested in this because I know the model fits very well with all my curves between 0 and 80 hours. But of course, like I said, you can change that. I'm also going to get my biomass yield here. 0 to 80. I can click to show errors if I want, or if I don't, I can also click that. Right, then you select create table. Yay, table is made. And here I've got my growth rate, which is grams per litres per hour at the top. Obviously, if you made your access, your time access to be in days, this would give you the result for grams per litres per days. And then here's my biomass yield. So about 1.867 grams for one of my reactants apparently. So then what you can do is you select save table and a box will pop up and you just say where it is you want to save it. Where am I saving this? 24 December, yeah. So this is transformants, growth rate, biomass yield. Save, and then you can then navigate to that folder, which was somewhere in here, December, and here we go. I'm going to open this up in Excel somehow. Yeah, there we go at the top. That's been annoying. And if you give it a second, Excel comes up. Great. So now what we can do is average. So growth rate is mu. So you can, because I did this in triplicate, I can then just very easily work out my average growth rate between the triplicate runs. Like this. Oh, not like that. Oh, all right. Too much coffee this morning. Average, that's how we spell it. And so on, and then you can also work out, your standard deviation if you want to do your error bars, or if you want to do standard error. I think technically you probably should be doing standard error. Oh, whoops, that's the wrong one. That's my biomass yield, so don't do that. You can then very quickly do so. Makes you a nice plot. One more, because I believe in freeze. Oh God. Voila. Then you can just plot of this, obviously. You know how to plot in Excel. And then what's nice is you can then do t-tests. Ooh, I put in the wrong error bars there, did I? That's strange. Oh, weird, okay. Very big difference in growth rate. You can then, do your t-tests basically. So you can then just say, obviously, like if you want to compare A1 versus A4, see if they're significantly different, the growth rate, you just do obviously the t-test function in Excel. So is that significantly different from that? And it is. So wonderful. So that's just how you can use growth rate function and the biomass yield as well. So you could also do exactly the same what I just did, but with the biomass. I'm a bit confused about this, but anyway. I hope that's helpful, and that means you can got a nice fit and you don't have to try fitting lines and work out with eye what's the best way of doing it. You can just use the growth rate model and also make lots of nice bar charts as well. So yeah, great. I'm going to now upload this to YouTube.